Cool. Let's get started. Thank you all for joining me. For those of you who were here earlier, thank you for coming back. My name is Perry Krug. I'm a principal architect with Couchbase. Been with Couchbase for about 7 years now, kind of touching all of our customers, large and small. Today I'm really excited to talk about a feature that we've added in our 5.0, or a set of features that we've added in our upcoming 5.0 release all around our index management. So indexes are global secondary indexes, and we'll go through some of those additions. Global secondary indexes, otherwise known as GSI, also known as the index service, something we added way back in 4.0 as a separate service that consumes data from the data service and builds up indexes based upon your definition of those through the Nickel query language. So basically create index on this field, starts an index running on one of the nodes of the service, and that's what then maintains itself when you want to do a query. It then uses that index. Before 5.0, again, these were introduced in 4.0. The first release didn't have any built-in kind of automatic management for replicas and rebalancing. You could still do it, but you had to kind of create yourself two indexes. And when you wanted to add or remove a node, you had yourself to kind of recreate an index, drop the old one, move that node, then put it back in, recreate the index. It worked, right? There was a process to get through it, but it wasn't very elegant. And with 5.0, we've kind of dramatically changed that, keeping the same interface and retaining that same control if you wanted it, but now adding the ability for indexes, as we'll see, to be automatically replicated and rebalanced and redistributed throughout the cluster, bringing it much closer to kind of how our legacy of the data service works, with just automatically managing the layout and the placement. So replicas just kind of very simply provide high availability for the index service. We'll see in a minute the syntax for creating them, but the automatic placement, when you say I want two replicas, it has a couple rules that it follows. Make sure that the one replica and or the one index and its replica are not created on the same node, because that defeats the whole purpose. That they are spread out across server groups. Server groups is a concept that we use for otherwise known as rack zone awareness, where in a data center you might have multiple racks. In Amazon you might have multiple availability zones. You want one cluster kind of spread across all of those, but you know that a whole rack might go down or a whole zone might go down, and you want anything inside of that to be replicated outside of that. And so even though you might have multiple nodes within a zone, the rack zone awareness, the server groups, allow you to make sure, or we will then honor that to make sure that one replica is in, or the indexes are replicated across groups. It takes a lot longer to say something that simple. And then we do try to do a little bit of work in resource or sizing management to make sure where we put an index is the place where it will fit the best. There's a lot of room for improvement there. Indexes can be of very different sizes and grow after you've already placed them. So we've got some kind of rudimentary placement resource allocation now, and that's something that you'll see kind of optimized in the future, so that we can add more and more intelligence about where an index and or its replicas should live. So that's the automatic placement. I just say I want two replicas. You can also specify I want this index to be created on these nodes, and specify a specific set of nodes, and we will create that many copies of the index and lay it out across those nodes. So if you have an index service of 5 or 10 nodes and you only want 2 copies, you can either have us pick which of those 2 nodes to put it on, or you can say specifically put it on these 2. And then any indexes that have the same definition, or in this case are replicas of each other, are automatically load balanced. So you don't have to worry about which index am I using. The query engine, as it responds to queries, will automatically choose an index, and if that index is no longer available, it'll fell over to all the other ones. And so that whole high availability load balance is all kind of built in. This is what it looks like. Hopefully at the end I'll have a bit of time for a demo, where's my mouse pointer? Somewhere over there. This end bit, the with num replica, is what's new. And so you say create index, give it an index name on a bucket, the field, and whatever kind of predicate and index definition you want, and then say with num replica equals 1. And that's going to create the index and a replica. So there's bound to be a little bit of confusion. Different technologies call their replicas different things. Someone says a replica of 1 is just one thing of it. Others say that you always have a 0th and one replica is the second copy. That's how Couchbase defines things. That's how our data service defines things. Whenever you say I want one replica, you're talking about one extra of whatever I created. So this is that same logic here. So one replica is going to be 2 copies of the index. That second statement with nodes allows you to specify the names of the nodes within the cluster where you want this index to be copied on. And so this will create 2 copies of the index, again, 1 on each of those nodes. All of the replicas are dropped together. They're treated as a single unit, and so drop index will delete and drop all of them rather than you having to worry about which ones have I dropped and where they are. We manage kind of statistics and status about the replicas a little bit separately. You can see that they are replicas. Each index has a name, and then we append replica 1, 2, 3, 4, 5, however many you want. In the index status, and then also the each instance of the index has its own statistics, and so you should see in a production system all of the replicas getting somewhat even requests, holding the same amount of data, taking up the same amount of size, but you can view them from an operations and kind of statistics management perspective. They each have their own set of those statistics. Any questions on replicas? Okay, we'll have time at the end for more questions. It's pretty simple. I'm really actually, I won't say surprised, but impressed at how simple we were able to make it. This whole placement and replicas and thing can be a very confusing topic, but in all of my interaction with this, it just works. You say I want 2 replicas, it creates those replicas, and then they're there and managed. Now, that management part of it, it's not just enough to create replicas and place them. You have to be able to manage the cluster and manage the distribution of it. And so the other part that goes hand in hand with creating replicas is the rebalancing part. As I add nodes, as I remove nodes, when I want to scale out, when I want to scale in, if a node fails, how do I recover from that? That's all around kind of rebalancing. And now with 5.0, the index service it has that capability in it. And I'll go through some of those examples. But generally, it just does the right thing that you would expect. If you remove a node, it's going to take the indexes off of that and lay them out elsewhere. If you swap one node for another, it's going to move the indexes from that node to the new one. And it makes sure that an index gets finished building before it activates it. So you're never in an inconsistent state that I'm accessing an index that only has half of my data, and it's not ready until it's fully built. Yes, question. I'm gonna get to that. I had the same question. I'm gonna cover that one. So let me just walk through a couple examples. As you want to, when you add capacity to the index service, this is the only case that we don't move the indexes. So this will be kind of well, let me walk through it. When you add nodes to the index service, those nodes are there, and then new indexes are created on top of them as you add more and more indexes. The other ones are left in place, and we made this decision because we don't have enough knowledge right now, enough heuristics to say I definitely want to redistribute these things. And so it didn't make enough sense to just move data when it wasn't the exact right thing to do. this is the only case where we don't move indexes, is when you're just adding new nodes to the index service and leaving the existing ones as is. However, every other case, as long as you're removing one node from the system, from the index service, those indexes will be redistributed over whatever the new topology is. So scaling in, if we remove one node of the cluster, it's going to replicate, it's going to redistribute those indexes to the remaining nodes. So if we went from 3 nodes down to 2 nodes, those indexes and hopefully the replicas, if there's enough nodes, will be moved. When you are swapping one node for another, let's say we only have 1 and 2 nodes and we're swapping, or sorry, the 1 and 3 node and we're swapping, we will move those indexes onto it. The interesting thing comes in when you actually want to redistribute the indexes. And in this case, if we take this example, we've gone from 2 nodes to 4 nodes, but we removed those 2 nodes, the original 2. And that signals to the system that I want you to redistribute whatever indexes were on there. So we added 4, we removed 2, and all those indexes got redistributed onto the 4. And same sort of thing, if I want to add more capacity to each of those nodes, I can add 2 nodes of larger RAM or larger CPU or larger disk, remove the 2 old ones, and anytime you're removing a node from the index service, we redistribute and take the indexes off of it. Does that make sense? So again, just the only time that we don't redistribute or move indexes is when you're just adding nodes. And this is kind of still from the old way of the 4.0 version. Anytime you add an index node, it comes in empty, and new indexes will start getting created on that. And so that behavior is maintained. What's added, or what 5.0 is, anytime you remove an index node, we recognize that there are indexes on there that need to be maintained, and they will be redistributed into the cluster, whether that cluster is the n-1 or whether you've also added some nodes to lay everything out against.
So if you wanted to automate the distribution of indexes from 2 nodes to 4 nodes of the same class, you would do it by adding 4 of the nodes, then removing the existing 2, and then it would automatically distribute one force auto distribution.
Correct. So the question was, if what you wanted was to take 2 nodes and redistribute things onto 4 nodes, you would add 4, because that's the new topology that you're going to, and you'd remove those 2. And the removal of nodes is our indication that those indexes need to be redistributed. And so your end state after the rebalance will be 4 nodes, because 2 came out and 4 came in. Yes? Good question. How many replicas should you be creating? It depends on the size of your cluster a bit. It depends on what your kind of expected number of nodes failing at any one point in time is. Certainly in a cloud environment, you may want to have more indexes, but you're then paying for that in storage and RAM costs, so it's a balance. You only need one replica to support the loss of 1 node failing, right? And so if you expect to be able to sustain the loss of 2 nodes, then you want 3 copies of the index. If you expect to be able to sustain the loss of more, you can choose how many you want to create. In most, I'll say almost all cases, you won't need more index replicas for performance. So 1 index can serve tens or even hundreds of thousands of requests per second. So although the indexes are load balanced, you don't need more indexes to reach higher levels of performance in most cases. It's more for high availability. Does that answer your question? Yes.
Just I think different classification question.
Okay.
If you need dual redundancy, you need 3 nodes.
Right.
Because at the instant you just threw a hand grenade into one of them, you only have 1.
Right.
You need at least 3, not at least 2. You said 2 copies for redundancy. You need 3.
Well, you need 2 if you want to sustain the loss of 1 node. If you want to sustain the loss of 2 nodes.
Dual redundancy with 2, you have to have 3.
Yes, but okay.
If you're a finance person saying, well, we were down 1, and then we had something happen,
Fair enough. You get the choice to choose how many you want. If you wanted 10 replicas in index, you can trade off the cost in storage and CPU and all that.
Failure has to be subtracted before you count what you redone.
Sure. If you want to be in an n+2 environment.
The hard way.
All of the indexes are updated asynchronously, so the more replicas you have will not slow down the update of any one of them. They're all streamed kind of independently from the data service, and all of that's done asynchronously, RAM to RAM over a network. So you're not going to get yourself into a situation where you think you have too many replicas and one of them is slowing down. They're all independent at the time of querying and being fed with data. Yes, in the back. The question was, do indexes subscribe to the rack awareness server groups? Yes, they do. And so in the server console, and you define these index nodes are in this group, and these index nodes are in this group. When you create a replica, it will be one copy of each index will be created within those groups or across those groups. Good question. The question was, will the query node direct the index to the one closest to it? I don't know the exact answer. I don't think it will today. That's certainly room for improvement. The query nodes are fairly stateless, and so at the moment they are not also part of the groups. So that's an improvement that we can make. Yeah. Good set of questions. So the question was, will my rebalance also rebalance my data, or is it separate for the indexes? All of our services are rebalanced independently of one another. So if you have only added index nodes and you have not changed the topology of your data service, then the data service will not change, will not be rebalanced. If you have index service on your data service and you're removing one of those nodes, both services need to be rebalanced in order to remove that node. But again, if you're only changing the topology of one service, be it query, index, data, or full text, that's the only service that goes through a rebalance. Make sense? Is there another question in front?
What happens if a single index node runs out of either memory or disk?
So the question was, what if a single index node runs out of memory or disk? Memory, we do a pretty good job of applying a limit to. When you create the service, you say it has a cap or has a quota. And bugs notwithstanding, we keep ourselves within that memory limit. And depending on whether you have in-memory indexes or disk-backed indexes, in-memory indexes, you will fill up memory and then it will stop taking new data in, but it won't crash, it won't break. The on-disk index will attempt to keep taking data in and use that and spill over to disk based upon the memory quota. I'll be honest in saying we don't have very good disk quota management, and so you can get into a situation where you fill up disk and the node is not able to keep taking in data there. That's one of the reasons why we recommend splitting your installation and logging directory from your index and data directories. That way, if one of those directories fills up, the node's not going to crash because it can't talk to its configuration or talk to its logs. If you don't have that and you fill up your root partition, the node's probably going to crash because it can't write its configuration or logging to disk. Okay? Yes, Mac? Yeah, so the question was, going back to that early comment that we don't redistribute indexes if you're not removing a node, are we working on the ability to do so? And the short answer is yes. What exactly that will look like and when, I don't know. We've got a couple kind of things in play about partitioning indexes transparently. And once we can break up an index, then we can spread it out more easily over nodes. The challenge is if we have one large index being the only thing on a node and then we have 15 other indexes, you have to take a lot of sizing information into account to know that one index can't be put on the same as those others, and it just gets more complicated than we were willing to bite off at this point. Yes?
So in previous versions we did this with duplicate indexes.
Yeah.
In
So the question was, previous to this capability, the way to achieve high availability with your indexes was to manually create duplicate indexes. And the question was, and this is where I don't think that it was entirely correct. The index service, the query service will only use one index. Whether you've created a duplicate or whether it's a replica managed, a particular query will only talk to one index for that data set. So your comment that it would send the request to multiple, it only does that when multiple indexes are needed to satisfy the query. But if the indexes are exactly the same, it's not going to send the same request to both and intersect the scan, and it still doesn't do that today. Does that make sense?
Yeah, I think we saw an issue in 4 and 5.
Do you remember anything, Benjamin? Oh, Asif.
So you're specifically talking about the optimizer and the array intersects 4.6.2 onwards, the intersect logic has significantly been improved. So what you're seeing there in the maximum plus 4.6.1? Yeah.
461?
2 onwards.
2. Okay. Which is out now. So by design, no, that shouldn't have happened, and it still by design shouldn't happen now. By bugs in the previous optimizer, some of that was happening. But that won't happen now as much as we can control it. One query should have one index, and that gets all of that data from that index. So some queries can use 2 indexes when you actually do want to do an intersect, but we shouldn't be doing an intersect when you don't need to, and that's just optimizations to the query planner.
Can you talk a little bit about how the actual index is picked by the query service?
Yeah, the question was how is the index picked by the query service? I don't have the specific algorithm. I know when we first started, it was just round robin, and over subsequent versions, we've been adding more and more heuristics about for a given indexer, when was the last time, what was the latency of the last time that it responded, and trying to avoid an index that has a very high latency. There's a lot of kind of moving improvements and optimization, so I don't want that to be the kind of the be all and end all of how it works. Go in the future, going to even more cost-based and being able to choose different algorithms, but in the beginning it was very naive, and it's getting better. Okay, any other questions before I move on? Okay, I apologize for this next slide. There's a lot of text on there. I think we covered some of it. Let me just see what else we don't have. Yeah, to your question earlier, thank you. I knew I would get to it. When you specify, and this is just skip all the way down to the last point, when you specify a number of nodes for that index to be replicated on and placed on, that is just for the initial placement. We do not remember those nodes and enforce the index to only sit on those nodes. You can see very quickly that it wouldn't be possible, right? If I rebalance that node out, how do I know that I've replaced it with something else? Or if I've completely rebalanced 3 times and moved the indexes all around, you no longer have those 2 nodes to maintain. So this was one of my questions earlier to the engineering team. Right now, we just don't. It's just for the initial placement. Now, if you do have a requirement to make sure an index only lives on a certain set of nodes, you more manually can say, I'm only going to rebalance that node in or out with the one that I want it to be replaced, and then you know that the indexes that were on that node will only be swapped to the node that's coming in. So maybe in the future there's a case to be made for kind of subgroups of indexes, but we need to figure out the balance between it's too complicated and making it work. Does that answer your question? Yeah. Question? Yeah.
On a single node cluster, if I create an index with a replica as one, will Couchbase allow us to create a replica since there's no meaning of
Right. So the question was, if I'm going to paraphrase the question. If I don't have enough nodes to create the number of indexes that I've asked for, you'll get an error. It won't allow you to create the index. I can see a case to be made for I want to create an index, let us recreate the replicas afterwards, but we don't do that now. So you need to have at least as many nodes as you are asking for replicas, and then we will maintain those in the future. Even if you go down below, when you come back up, we will recreate those replicas, but you can't do that from the start. Does that answer your question?
Because in case of data, a single node cluster, if I say replicas as one,
That's a good point. All right, there's a little bit of inconsistency there. Creating a bucket and saying I want this number of replicas, it will recreate them afterwards. That was a holdover from when we didn't have the ability to edit replicas on demand in the data service, so you had to set them up early. Now that arguably is not needed because you could change them afterwards. But the index service works the way I described it. Benjamin?
Can you change what's the correct way to change the number of replicas?
Good question. I'm going to skip over my next two slides. The question was, what is the best way to change the number of replicas after you've already created the index? The short answer is we don't have a single API to do it today. We're working on a command called alter index that will allow you to take this index and change it to a different one. So if I have only 2 replicas and I want to add a third, this command will, in the future, allow you to do that. Today, you'd have to do it more manually. So you would create a new index with 3 replicas and drop the old one with 2. And that has some resource requirements on it, but it is possible to do. We're working on making it easier to do. What we do have, and I'll go back a slide, is a move index API. It's not a nickel command, but with the command line or a REST call, you can take a specific index and relocate it to another one. And by a specific index, I mean a specific instance of the index. So it's if you have 3 replicas, you will only move 1 at a time if you had to move it off of a node and put it somewhere else. But that doesn't change the number of replicas that it has. And I don't know if you mess it up and try to put one on top of itself, I'm not sure what would happen. But okay, keep the questions coming in. I'm going to try to demo this a little bit if the gods are smiling favorably upon me. So I've got a cluster here. Right now I just have can you see that kind of okay? So I've got just a travel sample bucket installed. This is the 5.0 UI if you haven't seen it before. We've really redone the UI in 5.0. Indexes right now, I don't have any replicas, but I'm going to show you the creation of one. In the query, oops. So in the query, as I showed before, create index on travel sample. Let's create it on the name field with num replica 1 for now. What did I do? Syntax error. Oh, create name. Sorry. Thank you. IDX name, whatever we want to call it. No, what did I? Oh, thank you. Thank you. Does it look okay now? Oh, and it worked. Surprise, surprise. Okay, so this is creating an index. It says success. It was done. If we go back and look at the indexes, oops, wrong button. Back if we look at the indexes, we can sort by name. Right here. Where did it go? Oh, down there. I thought it sorted. There we go. Sorry, sorting. Name, replica 1, and name. And if we go and look at the statistics, down here we have statistics for the name and its replica. So now that was it. Like that's the demo of creating a replica. It's pretty easy. Now if I come back over here, let me see actually where that index is on. The name index is on this node, 5241.84. If I go to my servers and 5241.84, if I say I want to remove this index node, it tells you we're going to remove some indexes. Some of those indexes don't have replicas, but actually that warning is probably not as relevant anymore. And then click rebalance. To your question earlier, I'm only removing an index node, so the data is not being rebalanced, is not being redistributed. We are taking the indexes that were on that node and redistributing them out. If I go back and look at name again, it's now on a different node The index still exists. All of the queries that were going on were still succeeding. And yeah, that's the demo. Any other questions? Yes, another question. Sure, good questions. The question was what kind of tooling or statistics are available to monitor index performance. At a kind of an introductory level, we have each index for a given bucket has its own set of statistics. So if we come in here, you see that you have the number of the throughput, basically number of items scanned per second, how much size it's taking up on disk, how much of that disk size is the actual data of the index, how many items are pending, have not yet been indexed, how fast we're indexing items. Excuse me, how many items total are in this particular index, the rough average item size of those indexes, of those items, fragmentation, requests per second, bytes, and average scan latency from the index itself, right? So when a request comes in and by the time the index sends that out, that's the latency that it's measuring. The query service has its own set of statistics, again, throughput, but broken down by selects or not, any errors or warnings. We have a rough latency measurement, any queries that took over 250 milliseconds, any that took over 500, any that took over 1,000, any that took over that 5 seconds. We have kind of numerical statistics here. We also have a query monitoring facility, and this was added in 5.0. Come on. There we are. This query monitor, I don't have a lot of interesting stuff going through it right now, but we're monitoring all of the top X number of slowest queries. And so you'll see them here with the query itself, the amount of time that it took, and some identifying information. This is actually the query for getting those queries. So we do everything kind of through nickel. So if I had more queries going through here, you would see an actual query, but this is the query to get the longest queries. And so that's kind of always running. There's more information at a lower level. If you get into the logs, you can get explain plans. You can get the timings for how long each phase of a query took, and you can query all these statistics. You can get all these statistics through the REST API as well. One more added in 5.0. The query workbench has part of its explain plan timings built in. So if I do a select star from travel sample limit 5, I get the result, but then I can also go and look at the Asif, why isn't that working? Oh, there it is. I think there's a, anyway. So this is a visual representation of the query explain plan, and each phase is broken down into how long it took. And so you read from right to left. The authorize phase took, was that 6 nanoseconds? The primary scan to that bucket returned 5 items and took like 0.1 milliseconds, the fetch, the project, all of that. And so on a manual basis, you can see how long your query is running, but then the query monitor is monitoring actual queries that are running through the system versus kind of an admin poking around itself. Does that exhaustively answer your question, or did I miss it completely? Yeah, it's great. So most of this is new in 5. We did have a little bit of timings management in kind of 4.5, 4.6, but they were at a lower level, and we're just constantly expanding upon the management of it, the visualization of it, and even more granular timings. So the question was, this API in 4. Whatever is individual to each query node. They're now global. No, it's global now. It's clustered. So one query node will report for the queries running through all the queries. It was not in 4.5 or 4.x. Okay, we can chat about that. But it is global now. It is clustered now. How am I on time? I'm about done. 5 minutes or so. Any other questions? Brent?
So previously, when you were doing high availability indexing, you made two indexes. If you wanted to actually specify which index to use in your query, you would reference the list of the indexes that were options used in the query. With the replicas, do you just reference the primary name and it automatically goes out to all the replicas?
Good question. I should have. That's something I should have added. So the question was previously when you used a hint, in your query, you said use index because you wanted your particular query to use that index. You had to specify the name of the index, and if you had duplicate indexes created, the name for one was not the name for the other. It is now. So with replicas, we understand that the index has a name, and then there are multiple instances of it, and so you no longer have to worry about does my hint have the right index name in it. Other questions before I wrap up? Cool. Well, thank you guys for your questions, especially, and thank you for your time. Oh, one thing, just to, because I was asked to present these slides. The Couchbase Connect app, if you haven't already downloaded it, would have probably been useful like 8 hours ago when you